Hello friends, I'm attending Really they are very solid and department of people. So now I am going to give the lecture on envelope under the differential calculus. That is envelope of family of curves. That is under the unit 3, the subtopic. So let us know first what is meant by envelope. I think all of you know that envelope means envelope is a cover, and if it that is put inside something, it will cover that material. So in the same concept, they are going to define envelope in mathematics. So before going to define the envelope of family of curves will be there. So I will take the what is meant by family of curves. So by considering the example, I will define the family of curves. So let us take an example, that is x minus alpha whole square plus y square equal to a square. As all of you know that it is the equation of a circle with the center at alpha 0, that is on the x-axis. So in this, go on changing the values of alpha. That is alpha as alpha 1 0, alpha 2 0, alpha 3 0. You are getting different circles. You collect them all in one set and you are getting the collection. That is called as the family of curves. That means, suppose if you just, I will show it. That is, so this is the circle first one with the center alpha 1 0. Second is with the center alpha 2 0. Third one is with the center alpha 3 0. And fourth one is with the center alpha 4 0 and so on. In this way, if you get the different circles with different values of alpha, so collection of such type of the curves is called family of the curve, where the alpha will be on changing, that is called as a parameter. Therefore, in this way, that is system of curves formed in this way are called family of curves, and the quantity alpha is called parameter of the family of curves. So we can write in general equation of family of curves is of the form f of x by alpha equal to 0, which is in Cartesian form, f of r theta alpha equal to 0 in the polar form, where in both alpha is a parameter. So this is the family of curves. Next, we'll have the definition of the envelope here. Again, for the envelope, we'll have the same example. That is, if you go on drawing the circles very close to each other, that is, we draw the first one. Similarly, next we are getting second. And in this way, go on drawing the circles very close to each other. Then you can just observe the point of intersection of the 1 and 2. This is the point of intersection of 1 and 2. Second, point of intersection of the 2nd and 3. Point of intersection of the 3 and 4, and in this way. So you just see these points of intersection and the path joined by these points of intersection, not necessarily joined. I hope you can see this is a line. So this line covers above one and this below one. Both will cover all these circles. So you can say that this y is equal to this is a and y is equal to minus b. This is the envelope of the family of the curves. Therefore, in this way, you can define envelope as the envelope of any family of curves is at the locus of the limiting position of the point. Limiting position of the point means very close. Second is very close to the first. Third is very close to the second curve, and so on. In that way, you have to draw the curves there. So, position of the point of intersection of any two consecutive members means conjugative members means 1, 2, 2, 3, 3, 4 like that of the family. When one of them tends to coincide with the other, means you have to take second tends to very close to 1, third tends to very close to 2 like that. In this way, if you go on drawing, don't take the curves very far away. You are not getting the locus there. So that locus is called as the envelope here. Otherwise, sometimes the second definition, in that figure, the line is a tangent to all the circles there. So on the other hand, envelope is a tangent to all the curves in the family. So this is the definition. Usually definition is asked for the 2 marks. And next, what is the procedure for getting the envelope of family of the curves here? So let us the theory part. See, let f of x y alpha is first family or one family, and f of x y alpha plus delta alpha will be the conjugative family from the same set. We take two curves from the one family. and you take the point of intersection of these two. Point of intersection is always obtained by subtracting 1 from 2 or 2 from 1. So I will take that f of x y alpha plus delta alpha minus f of x y alpha is equal to 0 here. Now you have to make delta alpha tends to 0. So dividing both the sides by delta alpha first. So this to divide by delta alpha, 0 by delta alpha is 0 itself. Then take the limit because you are going to tending to the second, to the first, third, to the second, and so on. So take the limit delta alpha tends to 0. You can get this side with the partial differentiation of the function f with respect to alpha because there are the three variables. With respect to that, you are differentiating with respect to only one pair, that is the variable alpha. So dou f by dou alpha is equal to 0. So by using this, get the value of alpha, substitute that in equation 1, alpha will be removed, and that itself is the required envelope here. So common procedure, this theory part you are not having actually, hopefully you remember how to do it. So let the equation of whatever the curve is given, take it as 1, differentiate that partially with respect to the parameter, and give it is 2. From that to get the value of alpha, substitute in 1, you are getting the required, that is envelope of envelope. I hope you can follow it. So by seeing the example, you can come to know. See that is find the envelope of family of circles. Same example I will x minus alpha whole square plus y square equal to a square, where alpha is a parameter. I shown already by using the geometrical figure, and now you can prove it algebraically. So procedure I told already, take the given curve as 1 and differentiate that partially with respect to alpha. Differentiation of x minus alpha whole square is minus 2 times of x minus alpha plus y square is 0, x square is 0. Because while differentiating with alpha and all the remaining are the 0 itself, sorry, constant. Therefore, the differentiation is 0 there. That implies x minus alpha is equal to 0. Therefore, alpha is equal to x. This value alpha is equal to x you substitute in equation 1, that is x is equal to alpha minus alpha, that is x minus x whole square is equal to 0, y square equal to a square. Therefore, y square equal to a square means y is equal to plus or minus a. So y is equal to plus a is the upper envelope, y is equal to minus a is the lower envelope, already in the figure, that is, you have seen it. So once again, I will show that, that is the so envelope of family of the circles, you are getting it is y equal to a and y is equal to minus a. So if you draw the circles, one by one, the different values of alpha. So at the end, you can get the line. So this is one line y equal to a, this is another line y equal to minus a. So these are the envelope of family of lines. So if you see this figure, it is very beautiful, and such will be using in architecture. Next one, find the envelope of family of lines y equal to cx plus c square. Why these are the lines here? Because of the equations are in linear in x and y. Only the parameter c will be of a different degree here. Because of these linear in x and y, these are all lines. Families are always not necessarily the lines, they may be of the curve. So here, where c being the parameter. Same procedure, you take this as equation 1, differentiate partially with respect to c, differentiation of y is 0, differentiation of cx is c, x, differentiation of c square is 2c, therefore c is minus x by 2 here. So substitute the value of c equal to minus x by 2 with equation 1, you are getting minus x by 2 into x plus minus x by 2 whole square. So it is y is equal to minus x square by 2 plus x raised to 4 upon 4 is equal to, so it is not minus plus, it is minus x square by 4 we have to write. This is it. Minus x square by 4. So y is equal to minus x square by 4 is nothing but x square is equal to minus 4y. So this is the required envelope, and I hope all of you know this is the parabola. So the find envelope of family of these lines you are getting as a parabola here. Next one, find the envelope of family of lines. Again, because of linear inequity line, ax sin alpha plus dy cosec alpha equal to a square minus b square, alpha being the parameter. So here again, same procedure, you have to differentiate this equation partially with respect to alpha, differentiation of sin alpha cos alpha, differentiation of cosec alpha minus cosec alpha into cos alpha equal to 0. Therefore, it is ax cos alpha, dy cosec alpha into cos alpha. You are getting, write all trigonometric functions in one side. You are getting ax upon dy is equal to cosec alpha is 1 by sin alpha, cot alpha is cos alpha by sin alpha, and this cot alpha divided by this cos alpha. So it is nothing but 1 by sin square after simplification. So sin square alpha is dy divided by ax. Therefore, sin alpha is equal to root dy divided by ax, and cosec alpha is equal to root ax upon dy, reciprocal of this. So these values you have to substitute in equation 1, and you can get, that is ax into root dy by ax plus dy into root ax upon dy equal to a square minus b square. Simplify both the sides. That is just root ax into dy plus root dy into ax equal to a square minus b square. So it is same term, adding both, you are getting 2 times of root ax into dy equal to a square minus b square. It is 4abxy equal to a square minus b square. So that is what getting the required. Only getting the values of parameter and substitute and simplification. You are getting the required envelope. Then find the envelope of family of lines ax sin theta by cos theta equal to p sin theta into cos theta. So in this equation, r is in the form of sin theta cos theta. So dividing both the sides by sin theta and cos theta, you are getting ax sec theta plus dy cosec theta is 2. Take this as 1. Then differentiate partially with respect to theta. So differentiation of sec theta tan theta, cosec theta minus cosec theta cos theta, that is 0. So it is ax into sec theta tan theta is equal to dy cosec theta cos theta. All trigonometric functions you write one side and x and y in one side. You are getting tan theta is dy by ax. Therefore, tan theta is dy by ax raised to 1 upon 3. Then by using the formula sec theta is root of 1 plus tan square theta. Substitute tan square theta is dy by ax raised to 2 by 3, and simplify, you are getting sec theta is equal to, that is root of ax raised to 2 by 3, dy raised to 2 by 3 divided by ax raised to 2 by 3. Similarly, you are getting the cosec theta, and both values you have to substitute in equation 1. Cosec theta is ax raised to 2 by 3 plus dy raised to 2 by 3 whole divided by dy raised to 2 by 3. So these values are substituted in equation 1 and simplify. You are getting the equation as ax raised to 2 by 3 plus dy raised to 2 by 3 whole raised to 5 is equal to 3. So usually these type of examples are for the 5 marks, but for the previous simple examples are for the 2 marks. Next, find the envelope of family of lines x cos alpha plus y sin alpha is equal to p, where alpha is a parameter. So this is also very simple. Just differentiate this equation 1 partially with respect to alpha. It is x minus of x cos alpha, that is y sin alpha, and it is y into cos alpha. Differentiation of cos alpha is minus sin alpha equal to 0. So here removal of alpha you can use even for even previous procedure or another procedure using, already have done this in curvature. That is this equation and this equation, if you want to remove alpha, squaring and adding, you have to squaring and adding 1 and 2, then simplify 2xy cos alpha sin alpha minus 2xy cos alpha sin alpha will get cancelled. X square cos square alpha, y square sin square alpha equal to y square into cos square plus x square into sin square equal to p square. So here in these two, that is x square cos square, and here it is cos square, y square into there. So x square plus y square into cos square alpha, x square plus y square into sin square alpha is equal to p square. So that time x square plus y square is taken outside, remaining is cos square alpha plus sin square alpha, that is 1. So everything x square plus y square equal to p square. So envelope of family of the lines x cos alpha plus y sin alpha is equal to p. That already you know in PC first year you can study, that is equation of straight line in the normal form. So geometrically can show this figure. If you go on drawing the lines with the different values of alpha and same p. So draw these are x and y coordinates and draw the lines now. This is the line with one alpha, that is alpha 1, with the same p here, normal, and similarly same p, the normal, the same p, the normal, like that. With the same p and different values of alpha, you draw the lines. So go on drawing, and collection of these lines itself is family of curve, and you are getting that at the end, the intersection of all the this is you are getting as a circle. I hope you can feel it. It is a circle. That circle is x square plus y square equal to p square. So for some example, geometrically also you can show it. That envelope is a given. Then find the envelope of family of lines x cos cube alpha plus y sin cube alpha is equal to p here. So this equation here you cannot see because of this toolbar. I'll take that equation here and take this equation as 1. And again, same procedure, differentiate partially with respect to alpha, simplify, get the value of tan alpha, that is y by x. So use this triangle, alpha is this one, and y opposite side divide by, that is adjacent side. So hypotenuse should be x square plus y square. Then cos alpha by using that triangle, cos alpha is x by this, sin alpha is y by this. So you can get x upon root x square plus y square, y upon root x square plus y square. Substitute sin alpha and cos alpha in equation 1. So you can get, it is x cos alpha is x upon root x square plus y square cos cube alpha whole cube, and sin cube alpha is y upon root x square plus y square whole cube is equal to p. Simplify and bring this denominator this side. We were getting x raised to 4 plus y raised to 4 equal to p into root x square plus y square whole cube. So this is the required envelope. Yes, I hope you follow the examples how to solve, get the envelope of family of curves with one parameter. So, and there is another easy method to get the envelope without differentiating. But unless the curve is in the form of quadratic in alpha or in the form of a cos alpha plus b sin alpha equal to c. In both the equations, a, b, c are functions of x and y are constants. So here, this is also some easy method and you can use it for some examples. Otherwise, as in previous examples. So example, first one, find the envelope of family of curve where the quadratic in parameter. So just this theory is not necessary. Just to remember this one, envelope of family of curve a alpha square plus b alpha plus c is equal to 0 is always its discriminant equal to 0. That means b square minus 4ac is equal to 0. So first you convert every equation in the form of quadratic and get the value of a, b, and c and substitute. So I'll solve the example so you come to know it. So find the family of straight lines. Y is equal to mx plus a by m. So this is even for this you can use previous procedure, differentiating this partially with respect to m, get the value of m and substitute them. But here I am making this as a quadratic. So multiplying throughout by m is m into y equal to m square x plus a. So that I will write as m square x minus y into m plus a is equal to 0. So which is quadratic in m. And hence its envelope is by using that its discriminant equal to 0 in our. So here a is x, b is minus y, and c is equal to a. So b square means minus y whole square minus 4a into x. A into x means you are getting a here, and x is, that is a, actually c is equal to a here. C is equal to a and a is equal to x. So you are getting minus 4a. So you are getting y square is equal to 4a, which is the required envelope here. Though it is a parabola. Actually, if you in differential calculus you come across y is equal to my mx plus a by m is always the collection of tangents to the parabola y square equal to 4a. See, if we draw this with different values of m, go on drawing the straight lines here. So you are go on drawing the straight lines with the different values of m. It's a fixed a. So you are getting this curve, and that is in the form of the parabola. Therefore, you are getting y equal to envelope of lines y equal to mx plus a by m is parabola. So next example, find the envelope of family of lines y equal to mx plus root of a square m square plus b square. So again, it is not directly in the form of quadratic. So you have to make it quadratic. Take this mx this side. Y minus mx equal to root of a square m square plus b square. Or y minus mx whole square equal to a square m square plus b square. Expand this one and write quadratic now. So these must be first written in the form of quadratic. So it is coefficient of m square, x square as well as minus a square. So x square minus a square is equal to into m square minus coefficient of m is only one term, 2xy. Constant terms are y square minus b square. So it is in the form of am square and bm plus c equal to 0. So it is quadratic in m. So its envelope is its discriminant is equal to 0 here. So it is b square. B square is minus 2xy whole square minus 4. A is equal to x square minus a square and c is equal to I square minus b square is equal to 0. Simplify this. 2 square is 4. That 4 and this 4 will be cancelled. So after simplification, just you can get x square y square terms, x square y square terms get cancelled. 3 terms you are getting. Bring a square b square this side. It is x square into b square plus y square into a square equal to a square into b square. So dividing both the sides by a square into b square, we are getting x square by a square plus y square b square equal to 1. So for this straight line, if you go on drawing the lines of that type with the different values of m, you are getting collection of the curves and the point of intersection of all those curves for another curve that is in the form of ellipse. So this is the required envelope. Similarly, I hope you can draw this, that will be straight line, envelope of family of lines, that is y is equal to mx plus a into root of m square plus 1. So I hope you can do it same as the previous example where m is the parameter. Then second type, a cos alpha plus b sin alpha equal to c if is the given curve. Then directly you can get this, its envelope as a square plus b square equal to c square. So just we solved already this example. So by using this, what is the envelope? A is what? Coefficient of cos alpha, that is it. B is coefficient of sin alpha and c is this constant. So you can get x square. A square means x square, b square means y square equal to b square. So very easy to, if it is in the form of x cos alpha plus y sin alpha equal to p. So if such type will be there, they will ask it for the, that will be 2 marks. And in the place of x and y, any other functions will be there in the form of x square or y square.